What's up everybody, I am not a software engineer, but in my last video we were able to successfully create an aim trainer using Python and Pygame. And I got to thinking, I'm really bad at this because my aim is really bad, so is there a way that I could potentially use computer vision to cheat? And the reason I thought this is because the target is actually just a 60 by 60 pixel red square. And so in theory, using computer vision, you could probably detect the color red and then maybe jump the mouse to the actual target. So let's go ahead and see if we can figure out how to do this in Python. So similar to the start of my last video where we actually created the aim trainer from scratch, I'm going to go ahead and use the aim trainer as a template, right? And the reason I'm going to do that is because I don't want to necessarily add our aimbot functionality in the original aim trainer repo, because I still want that to kind of exist for the purpose of just creating the aim trainer. But I have enabled the use this template feature, so I can basically go ahead and create a new repository based off of that. And I'm just going to name it aim trainer aimbot. And that should differentiate it, yet keep it relatively close to the original aim trainer. So I'm going to go ahead and make this public, and let's see. I'm going to copy all branches. Actually, no, I think we're good. So I'll go ahead and just create the repository from template. And of course, I need to go ahead and clone this locally. And this is basically what we had when we did the final commit to aim trainer. Of course, now this is in aim trainer-aimbot. So we can go ahead and start modifying a few things. And before we're able to run this, of course, we have to add our font to the graphics font directory, which I have done after doing my git clone. So we can basically just run this with PowerShell, doing python main.py, and just test that the aim trainer works, and it does appear to. So we're going to visualize this simply by having an enable aimbot kind of button right here that listens for a mouse click, and when that click happens, we'll enable cheating in the actual game, right? Which will then allow us to use our to be created computer vision aimbot. So what I'm going to do is, instead of creating the images, I'm just going to kind of copy and paste them into our graphics directory. And I did make these in Photoshop using 1920 by 1080 as my resolution. So we're going to go ahead and copy those over. So within our graphics directory, we now have an aimbot on file, which is basically just this transparent background with our font, and it says, enable aimbot, and then it has the check mark. And then our off is the same exact thing, but it does not have the check mark in the box there. I also have created a similar square that will fit around the target that we have. This will basically be how we demonstrate that we have detected a target. So now what I'm going to go ahead and do is go back to our main.py, because we need to listen for a mouse event, and we'll basically change which enable aimbot screen that we are showing on the wait screen in the beginning. So remember, this is going to be in our game state waiting. So basically what we're going to do is we are going to have an event type that we listen for here, and I'll go ahead and create another elif, right? And so that will just be elif event.type equals pygame.mouse button down, and self.gamestate is equal to waiting. Then what we're going to do is toggle aimbot. So if event.button equals 1, and that's just going to be the left mouse click. We're going to do a self.cheat is the opposite of what self.cheat currently is, so you can do that simply by putting not self.cheat, and that takes the inverse of the current value. And then we'll also do self.title.aimbot enabled is the inverse as well, so not self.title.aimbot enabled. So right now this is just changing basically a setting that we have not defined in our init function. So I do need to go ahead and add that to our init function, and I'll do that here. Boolean to keep track of whether or not to use aimbot. And then I can just put self.cheat, and we'll set that to false as kind of the default value when we init our game. So we basically have an event listener that wants to see if we're enabling cheating, right? But right now this doesn't actually do anything other than change the value of self.cheat. And we also don't have aimbot enabled in title. So what we need to do is go over to our title screen, which is available to us in title.py. And I need to basically create a new init statement here, which is going to be self.aimbot enabled equals false. So our default value, of course, is false. And now we need to have something that basically renders a different image based on what the status of aimbot enabled is, right? So what I'd like to do is have a new line item right here, and that's just going to be aimbot on, and then we'll have pygame.image.load graphics aimbot on.png, and then of course we will convert that. And then the inverse of that, of course, is just going to be aimbot off equals pygame.image.load graphics aimbot off.png .convert alpha. And so we need a bit of logic that basically checks to see if we have aimbot enabled, right? And so I would like to do that here in this section at the bottom. And I can do that right under the title image. So if self.aimbot enabled, self.display surface.blitz aimbot on. And since this is a 1920 by 1080 image, we can simply do that at position 0, 0, and it will line up. So in the else block, I will have self.display surface.blitz aimbot off. And then we'll place that at 0, 0 again. And at this point, I think we should be able to run this and get that option. And so we see our enable aimbot. I can click and that enables aimbot, and then I can click again and it disables it. Of course, we don't have any functionality for when cheating is on, but at least we have this button. And the game just runs normally, even when aimbot is enabled. It's not actually doing anything. So we'll go ahead and close this. And now what we're going to do is create a new file, and that is going to be aimbot.py. So this is the fun part. We need to import a few things here. First of all, we need settings. So from settings, import star. And then we're actually going to be using computer vision as mentioned. So import CV2. And then we're going to use IO and Pygame. And lastly, we need numpy. So import numpy as np. And we're going to create a new class for our aimbot, and that is going to simply be called class aimbot. And we will have our def init function, which takes self as a parameter. And we're going to set a few things. Of course, we always get a display surface, so self.display surface equals pygame.display.get surface. And then we also need a boolean for whether or not a target has been identified. So we're going to do self.target identified equals false. And then we're going to have basically a variable to hold our contours, which is how we detect the red colors in the actual target, right? So self.contours is going to be equal to none at first because we're not going to have any in the init function just yet. And then we're going to have a self.detected x value and a self.detected y value, and they're both going to be none to start. So none, none. So we need a function that is basically going to detect our target, right? In this case, just the red image. That is the 60 by 60 square. But I'm going to call this function detect target. So detect target, and that is just going to take self as an input parameter. And so now what I want to do, basically the logic of this is every time this function runs, I want to take a copy of the screen, kind of like a screenshot, right? And when I take that screenshot, I want to begin my computer vision on this. And since this is a computationally intensive operation, I do not want it to happen every frame. Because remember, we're running this at 120 frames per second. If I did this at every frame, it would not run very well. So I really only want to do it once, and then I will flip the value of target identified to true, and then this will not run when I have an identified target. So What I'm going to do is basically have some logic after we create our function that determines when detect target runs. But for now, we're going to go ahead and just build this out. And that is going to have basically a screen copy, which again is what you can consider to be like just a screenshot of what is currently going on in Pygame. So pygame.surfArray.array3D on our current display surface. So self.display surface is what we're going to grab that array 3D on, right? And we're going to keep modifying this variable because we're going to do a few things that allow us to analyze it with computer vision or OpenCV, which again is imported as CV2 right here. So I'm going to basically copy this because I'm going to be modifying it quite a bit. I'm going to have another screen copy equals cv2.cvt color, and that's going to take itself as a input parameter screen copy, and then cv2.color, and this is what we're going to change basically the color values to something that CV2 can read, which is going to be BGR2RGB. And so that's kind of like the inverse, and it's going to place that into RGB values, which again is blue, green, red, to red, green, blue, if that makes sense. And then I'm going to basically rotate this. So screen copy equals np.rot 90, rotate 90 degrees, screen copy. And then we're also going to flip up down. So np.flip up down, screen copy. And lastly, we are going to flip left right. So np.flip left right, screen copy. And now we should have something that we can read with OpenCV. We still need to do a couple things though. So we're going to take basically an input that is not used, which is what this underscore is, and then we're going to have buffer, and we're going to have that equal to cv2.image encode. We're going to encode this into a JPEG, and then again the input is screen copy. And then we're going to get the bytes version of this, which is where our IO import comes in. So file bytes is going to be set to io.bytes IO. And then our buffer is going to be the input parameter there. And lastly, we're going to have the image decode set as find target. So cv2.m decode. And we're going to have np.from buffer take the file bytes.get value. And then it's going to basically take that as numpy.uint8 modifier there, and then I'm going to have cv2.mread color. It's basically letting you decode the image in a way that OpenCV understands. So we need a hue saturation value image, or HSV image. We're going to set that to cv2.cvt color, and then we're going to take find target as our input parameter, and then we're going to do another one of those cv2.color blue, green, red to hue saturation value. And then this is the fun part. This is where computer vision is actually doing its thing. We are going to have kind of a lower bound and an upper bound for what we consider our red color of interest to be, right? So I'm basically on this LifeWire article that's discussing how to use the HSV color model, which you can see red falls between this 0 and 60 degrees. This information here is what I'm using to help us create our lower red boundary and our upper red boundary for use with NumPy array. So I'm going to go ahead and go back to the code here and define lower red as numpy.array. And then we're going to take 0, 50, 50 as the lower bound. And then I'm going to have upper red set to np.array. And that'll be 10, 255, 255. So now I'm going to create a mask that basically is going to look between the lower and upper range there on our HSV image. So mask is going to be equal to cv2.inRange HSV image, lower red, and upper red. And then I'm basically going to save this in two variables. One is going to be self.contours, which currently is set to none. And the other is going to be our hierarchy. So we'll have self.contours and hierarchy. set to cv2.find contours, and this is going to use our mask, and then we're going to use cv2.retr tree and cv2.chain prox simple. So now that we have self.contours and it actually has a value, which again is kind of the output of this find contours, and we can actually check the docs out, and basically a curve joining all continuous points having the same color or intensity, right? So when we're looking for a red square, contours is essentially how we find that. But now that we have this output that is stored in self.contours, we basically need to look through that and get some information about it so that we can draw our detected rectangle around the appropriate location, right? So our graphics detected.png is going to go around our square. In order to do that, we need to get some coordinates that we can use. So we'll go back to aimbot.py, and we're basically going to do for CNT in self.contours, and CNT is going to be our contour value. Of course, this needs to be self. And I will basically look through that. So get the rectangle bounding contour. And we're going to store this as x, y, width, and height. And that will just be cv2.bounding rect. And that will intake the current contour. Then we're going to get the aspect ratio. Aspect ratio. And that's going to be a float of the width divided by the height. And then we're going to get the area as well. So area equals cv2.contour area, and that will intake the current contour as a parameter. And so what we need to do is basically look to see if the aspect ratio is around 1, right? Because we're looking for a square. And then we're going to draw the rectangle around that image. So we're going to do an if statement. If aspect ratio is greater than or equal to 0.9 and the aspect ratio is less than or equal to 1.1 and the area is greater than 100. We're going to draw the rectangle on the original image. So in order to do that, we need to create a cv2 rectangle. cv2 underscore rect equals cv2.rectangle find target. And then we're going to use our x, y value and then our rectangle coordinates. That's just the x plus the width and the y plus the height. And then we're going to do a 0, 255, 0 as the RGB value there, which is just green. And this is a bit redundant because I think this actually might be drawing a rectangle that is green, but we're actually going to be using a PNG image anyway. So I'm going to create a new surface, detection surface equals pygame.image.load, and I'm going to have this called detection image, which currently is undefined. So I need to go over to settings.py and create a new value here, detection image equals graphics detected.py. Then I can go back over to Aimbot and I will create a rectangle, detection rectangle equals detection surface dot get rect, and the top left is going to be equal to our width minus the width of the rectangle. So that's going to be 1920 minus 60 gives us 1860 minus x minus 10, because we're going to have, and we go back over to this graphic here, this is bigger than 60 by 60. I think it's 80 by 80. And so that's going to give us a little bit of space between the outer line and the actual target, right? So you can actually tell that that's a little bit bigger. So I'm going to go back to aimbot.py, and then we have something similar for our y value, which is just going to be y minus 10. So then I want to get the detected x and detected y values that we initialize to none and none. And the way that I can do that is self.detected x and self.detected y will be equal to detection rectangle dot center x and detection rectangle dot center y. And I'm actually going to use these here in just a moment. This top left value needs to actually have an equals sign, and that should fix that. Cool. So once we've done all that, we basically need to change our Boolean value of target identified to true. And so I can do this at the same indentation level, basically after this for loop completes, self.target identified equals true. And so I'll only do this while self.target identified is set to false, right? Because this is computationally intensive. I do not want to do this 120 times per second. So what I'll basically have to do now is have a new function called draw outline. And I will define that as draw outline, which will take in self, x, and y, because that's going to be the coordinates of where the outline actually gets drawn. So I need to check the values of x and y and make sure that they're not none. So if x not equal to and y not equal to none, I will create a new detection surface. Detection surface equals Pygame .image.load detection image, and then I will have the detection rectangle set to detection surface .get rect, and then we'll have a top left value of x minus 40 and y minus 40, and that is because we're passing in the center x and center y values, and again this is an 80 by 80 image, so in order to get the top left we basically just need to subtract 40 from both the x and the y value. And then I can self.display surface.blit detection surface at the location of the detection rectangle. So what I'd like to do here is listen for a mouse click, actually the left button being clicked. And if it is, then I'd like to actually jump to the target that I have identified. And that is the magic that Aimbot uses, right? Especially this Aimbot is that we're going to detect the location of our target, and then if we're pressing the mouse button down, we're actually going to jump to that location after we draw the rectangle around it. So if pygame.mouse.getPressed, and then the button we're looking for is the 0 index, which is just the left mouse button. If that is the case, we will jump mouse to detected target. And we can do that with pygame.mouse.setPosition. And since we inputted detection rect.center x and center y, we should just be able to use x, y as our position here. So lastly, before we create an update function, I need to have a reset detection function, which will basically do this again if needed, right? So after we jump our mouse to the target and we destroy the target, we need to reset our value of target identified, and we need to do a few other things. So we're going to create a function to do that, and that's going to be reset detection. And that's just going to take self as an input. So we're going to take our self.target identified, and we're going to set that to false as mentioned. Then I'm going to take self.contours, set that to none. And finally, self.detectedX and self.detectedY are both going to be reset to none, none. So this basically looks like the init function, other than getting the display surface. And now we can move on to update. Before we do that, I'm going to have a couple of comments here. So we're going to read the display every tick and identify/highlight target. Actually, I think that is sufficient for our comment. So I can then just have def update self. And here we can have if not self.target identified self.detect target. And that will run our big computer vision function here. Elif self.target identified and self.contours has a value, we'll simply self.draw outline self.detectedX and self.detectedY. And that should do it for aimbot.py. So recall that we made an aimbot update function that is not actually being called within countdown.py. So we need to go over to countdown.py and actually modify it just a bit. We need to get the aimbot status, and we need to store that in a variable. So if aimbot status self.aimbot equals aimbot. And in that case, we'll actually instantiate the aimbot class. And of course, in order for us to do that, we need to have an import statement from aimbot import aimbot. And then of course we need to have some logic down here, an update that says if self.aimbot status self.aimbot.update. All right, so now we should be able to give this a shot. Assuming that we pass in the argument that we just added to our class, which of course will be in main.py. So when we create our countdown constructor, we will pass in self.cheat, which again is a Boolean and will be initially set to false. But in the case that we actually enable aimbot with our button, that will be true. And so that aimbot status will then be in countdown.py. Assuming that we store that as self.aimbot status. And this should be self.aimbot status as well. And I also have this set incorrectly within aimbot. It should be flip UD. And I'm calling detected.py rather than PNG. Okay, so we got our green box. Let's see what happens. And it does jump my mouse to it, but it doesn't actually reset the detection, it looks like. And we need to go back to make sure that we're calling our reset aimbot. And we are not actually calling reset aimbot. In order to do so, we need one final elif statement, which is going to be elif self.cheat and self.gamestate equals playing. And then we're also going to listen for the mouse getting pressed. So we're going to have and pygame.mouse.get pressed. And of course we're looking for the left mouse button. Then what we're going to do is self.clickCount. We're going to add 1. And then we're going to play the shot sound. So self.shotSound.play. And then we're going to do self.countdown.targetGroup.update. And finally, self.countdown.aimbot.reset detection. So, in order to make sure that that works properly, this needs to be set to and not self.cheat. And I think that should set everything correctly. So if I go ahead and run main.py, enable aimbot, and hold down the mouse, you can see that our aimbot is working correctly. And as mentioned in the aim trainer video, I basically had the score output at a larger font size, depending on how high the score is, right? So at this 28,000 score, which is significantly bigger than what we can get by not cheating. We'll go ahead and compare really quick. Obviously the score is much less impressive in both the output font size and the numerical value. But we did notice one weird thing that I want to figure out is that basically I didn't reset the value of enable aimbot after the game. So I'm going to go ahead and go back to my reset game function and disable aimbot. And actually we already have kind of a reset game state section in our event listener. So under the elif event type pygame key down and self game state equals game over, we will reset the game state and clear click target details. So what I'd also like to do if the space bar is pressed, which again that takes us back to the title screen, is self.cheat, self.title.aimbot enabled. And we're going to set both of those values to false. So now if I go back and run this, of course cheating, I actually beat my previous high score. But if I press space to try again, as you can see, the enable aimbot is no longer checked, and we basically start brand new. So at this point, we have successfully created a computer vision aimbot for use with my aim trainer. And as you can imagine, it gets significantly more complex when you have something other than a red square to detect. But as a proof of concept, this really kind of goes to show you that computer vision can absolutely be used to basically jump your mouse cursor or your crosshair or whatever to a target, and thus is a viable method for creating aimbot. So in closing, I just wanted to say if you have any comments or questions or you had any issues getting this to work, please leave them in the comments section on the video. I will do my best to get back to them. Thank you so much for watching, and I will see you in the next one.